Hello guys, my name is Michal Hucko and welcome to another Pandas tutorial. In this video we're gonna talk about basic data operations in the Pandas data frame. Now this video will be very specific because most of the time when you will be working with big data, one of the most common tasks will be the data analysis or the exploratory analysis. This part of the video or of the course will cover some basic data analysis tasks in the exploratory analysis of data. So let's jump right back into the Jupyter lab and I will go directly into the 7th Jupyter lab labeled with the number 7. Feel free to go with me. You can find the data and the Jupyter labs examples linked in the GitHub description, link in the GitHub link in the description below. So as you can see, we are reading the same data frame from the CSV, train CSV house prices dataset folder. As you can see, we have 1460 rows, 81 columns. So the same data as we are using through the whole tutorial. Now, first of all, let's check the data types. As we have the data frame, you remember the dtypes attribute of the data frame. Because the dtypes attribute returns the series, as you can see over here. So I will cover some of the examples in this separate notebook in the next tab. Don't forget to read the libraries. So as you go and put here the dtypes, you will see that this is a series object with 81 objects, and each of the object is for a separate column. That's the reason why there are 81 objects in the series. Now we want to know how many distinct values there are. This task is quite common. You almost want to know separate distinct values in case of categorical data like texts, columns and object columns. And this is exactly the example. So in order to get the distinct value counts for each of the unique values in the column, or in this case the data types, you run the value counts method for the Pandas series. Don't forget that you can run these value counts for any column. So let's say you will choose any other object column and you will run value counts upon that. So as you can see, based on this cell, there are 43 objects, so string or text-based like columns, 35 integer columns and 3 float columns. Now you can divide the whole data frame into variables which will cover each of the columns. So as you can see, don't forget to log, because we want to have the reference to original data frame. In this case, that's the reason why I'm using the log. If you want to have the copy of the data frame instead of the view of the data frame, so you will just append at the end the copy method. Okay, so I'm splitting it into integer columns, object columns, and float columns. As you can see, there are only 3 float columns. One is the lot frontage, MS, VNR area, and garage year built. So again, if you want to know more about these columns, there is this description data where you can find the description of this file. The most important part of this example is that sometimes you want to split the data frame or the columns of the data frame based on the data type, so you can then manipulate with these columns more easily. Now let's go and explore some values. Let's just talk about the object columns, so the string based or text based like columns, and we're gonna put it into the data frame directly. So before we were talking about the columns, we separate the columns part. Sorry, it wasn't the data frame. Now we are separating the data frame like this. So as you can see, they are always like text based. So you can run the value counts as I mentioned in the previous cell. So there are a couple of MS zoning parts like RL, RM, FV, and so on. So let's just jump right into the data description and see what does MS zoning means. And it's that identifies the general zoning classification of the cell. And A stands for agriculture, commercial, floating village, residential, industrial, residential, high density, and so on. So the most occurred one is the RL, which stands for the residential low density, right? So these are the most occurred houses based on this type in the data set. So this is the output of this short part of the exploratory analysis of data. You can create this analysis also for the LE, and there you can see that there are some two types of the alley. Let's just jump right back here, alley, and there is a gravel, paved, and no alley access. So the thing which I want to show you here is if you sum these like numbers, you mostly get the number 1460 because there are that many columns. But as you can see here, if you sum these numbers, there are only 91, right? So 91 is much less than 1460. And now the question is, well, so why don't we get, after summing all these unique distinct value counts, the number 1460? And the answer is the nonce. As you saw here in this head, for example, there are these nonce occurring sometimes in the data. And now the question is, well, Michal, what are these nonce? And it's like in the data analysis world, sometimes you don't have the value for a certain specific column. Like for example, in this case, there are some houses which don't have the alley, right? So in this case, you need to put there some value which represents like no value, right? It's funny, like the non-value is representing basically no value. It's something like not a zero, but basically that there is no value really, right? So the Pandas is using for this purpose something which is called none. It can be translated as a not a number. It's a numpy object, so basically none is a numpy object. It's something like not existing number, right? And there are a couple of functions which are used to identify nonce. And nonce can cause a lot of problems in the data science world. So it's a good practice to start to learn how to handle these nonce. Now, these nonce and handling the nonce can be very like a higher grade topic, and we will cover this more deeply in the future like machine learning basics course, where we're gonna talk about this issue. But right now I just want to show you the most important essential parts of the solving the none problem in the Pandas data frame. So for example, let's go back to the alley. And as you can see, when you run command like this, so let's go to df and we want to have the alley. Don't forget that you can use also the square brackets, and you can see there are so many nonce, right? So there is a function which is called, so how do you select a nonce? So in order to subselect a series or a data frame, you need to have these series of bools, right? So we need to somehow transform these into bools. And there is a function which is called isNA, which returns true and only there when there is a none value in the given element, right? And then when you go here and you can ask, there are two built-in functions in the Pandas, in the Python in general, which are called an all and any. And now any returns true if there is at least one true in the series of Boolean objects. And now all returns true only if there are all true values in the series of a Boolean series. If there is all true objects in the series of Boolean, right? So this is quite handy functions which can help you to identify the columns with at least one value, and then you can deal with these columns separately, right? So let's jump right back, and as you can see, there is a so just to show you that diffy objects MS zoning, for example, has no non-values. So some columns may not have the non-values at all, right? So you just should be aware of this fact. Now sometimes when you want to teach your computer machine learning task, you are not satisfied with nonce because the computer don't know what to do with none, and you need to somehow solve it. And there are a couple of ways how you can solve the non-value problem. So one of the solution is to delete all the rows where is at least one non-value, right? So you can iterate through all of the rows, and if there is at least one none in whatever column, the given row will be deleted. Now, this can be quite tricky. For example, in our case, you can accomplish this with the built-in function called dropNA, right? The dropNA will do exactly like this. It will iterate through the rows, and when in the row is at least one non-value, it will delete the row. But in our case, when we run the dropNA, as you can see here, we won't get anything because there is at least one NA value in each of the row, right? So this is not our solution, right? So let's jump to something else, right? So for example, let's drop rows based on a none in a certain column. So let's just jump to alley and drop the rows where just the alley is none, right? We don't care about the other nuns, right? Maybe we won't use it. We will subselect the data frame and we will don't give a don't care about the other columns. So let's just don't handle other nuns, just the alley none. And in this case, you can just select the alley, get the not NA, like not NA is the opposite of is NA, right? So it returns true if there is not a none and false if there is a none. And then you can subselect the data frame this way. Please don't forget the log there if you're gonna index this index this data frame, so you don't have this beautiful warning sign from last video, right? So, but we end up only with 91 rows, so we lost about 1,300 rows. Well, this is not a good idea, right? So let's just go and try to find a none where, well, but 91 is better than nothing, right? So the none problem is quite a big issue and you need to somehow deal with it, right? In the future videos, I will cover more approaches how to do it even better, right? So let's talk about finding none in a subselect of data frame, right? So let's delete rows where at least one of two columns has a none. And this can be quite challenging because, let's see, first we need to subselect a data frame for a given columns, right? This returns a data frame, right? As you can see, there are some nuns, blah, 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 right? And then we want to see a not NA. And when you run this upon a data frame, it returns something like this. So for each row, for each column, there will be a one value whether this is none or not. And then we are going to do a little trick. It's called applying a function for each of the row. And when you apply is a magic function. It's connected with the functional programming, and if you are more into MapReduce function, MapReduce filter programming, it's a very essential basics of programming. And maybe I will create a video about functional programming in the future. So apply, what we'll do, we'll take these as an, let's say, array of arrays. And when you put the apply, you should put a function which will be applied for each of the array in array of arrays. And we want to have any, and we want to apply it row-wise, right? So well, in this case we are applying it column-wise, right? So if you run it like this, apply equals 1. Sorry, axis equals 1. We are applying it row-wise, and there you will see that only if there is at least one NA. Only in this case, only if there is at least one valid value in the row. Only in this case, we gonna return the row. So basically what this does, it will filter the columns, filter out, like delete the columns when there are two NA values in the rows, right? It's quite simple, quite easy. Try it on your own and try to understand this code, right? So, and then let's talk about integer values. One of the common approaches in the integer rows and columns is to replace the NA values with the average of the columns. So let's say you have a column with garage year build, and you have some garages which are missing the year of the build, right? And so you're gonna replace this NA value in this column with the average of all garages. You can say, well, but this is quite tricky. Well, why it should be helping? Well, in case of garage, it's not quite a good example, but sometimes when you are like filling out, for example, the coordinates, you have a column with coordinates, with the x coordinates, and one of the coordinates is missing because there was a measure error, right? The device was not working, which was measuring these coordinates. So you will put there the average based on all the values, and this can be very helpful in this case, right? So let's first, like, how do we get the numerical columns only? Yes, we have a value for integer columns, we have value for float columns, we have value for object columns, but we want the numerical columns. So one of the easy cheats, which can be very handy for you, is, so first we filter the columns in the data frame, and then from these columns we minus the names of the object columns, right? So as you can see, the object columns, I will put it here. So the object columns, I didn't build it, so let's go back and build the object columns for you. So object columns. So object columns is a list of name of the columns, and when you go to the F columns, you get the list of columns, and now you can call a method called difference, where you can minus the object columns from this, and this will return a subset of it. Okay, so these are only the numerical columns because I differenced the object columns from that, right? And then you can subselect it, ask if there is any, and then you can apply any the same way as we did before. Don't forget the axis, please, right? And then you can just put it into the data frame, right? So as you can see, there are certain like columns where there is at least one NA from the numerical ones. So yeah, this output is saying which of the columns has at least one NA value in the column, right? So as you can see, the MSVN area has some NA values, but let's concentrate on the garage. So the garage has at least one non-value, and we're gonna replace every non-value in the garage year build with a mean of the garage year build, and this is exactly what's happening here. Note that we are selecting the garage year build. Yeah, but this is quite funny because I made here a mistake. Why? Because in this case we will replace everything with that, right? So this is not good. So the best part is to use it like this, right? So this time we are selecting the rows where are the NAs in the garage year build. We are selecting the column garage year build, and then we are replacing it with the mean. Okay, so please, as you can see, I made a mistake. I just fixed it. So don't worry, mistakes are normal, and you can fix them immediately. So this is how you can replace it with the mean. But sometimes you want to replace it with the max, so you put there the max. Yeah, and don't forget, please, to put these things here, right? So here and here and here, right? So you can put there the max, mean, the median, whatever function you want. More about this function in the future videos, right? So feel free to Google it. There are a couple of statistical functions connected with the columns, with the pandas. It's easy. If you want standard deviation or other stuff, everything is on the internet. Right, so this was how you can handle the NA values. But when you are analyzing a dataset, sometimes you want to get some more info about specific column, and this is where the describe comes handy. So if you run a describe upon a dataset, it will give you this statistic about each of the columns. So for example, it says how many rows are there, that's the count part. What is the mean of the given column, that's the mean part. Standard deviation, mean max, 50% quartile, 75% quartile. A max value, right? So and this is mostly applied and useful for the integer columns, right? So what will we get if we have the object column? So for example, if there is a garage type and you run the describe, it's saying the count, how many unique values are there, what is the top value, and what is the frequency of the top value. So very handy information just from one method of the data frame or the series in this case, right? So, and this is for the garage year build because it's a integer value. Okay guys, this was quite exhausting and like a more in-depth video. I hope you get something from this video, something helpful for you. Thank you very much for watching. If you have any questions, comments, leave in the discussion below. I hope I will see you in the next one. Thank you very much. Have a nice one.